Last class we have
In
discussed
the
in
last
the
session,
last
we have
session we have
discussed about
discussed
the
about the
basic needs
basic
in
needs in
speed
speed
control of
control of
DC
DC
machines.
machines.
That means we
That
have
means we have
discussed about
discussed about
the
the
what are the
what are the
factors
factors
affecting the
affecting
speed
the
control
speed
and the
control and
different
the
types
different
of
types
speed
of speed
control of
control
DC
of
series
DC
motor
series
and
motor
shunt
and shunt
motors.
motors.
How we are
How we are
controlling by
controlling by
using
using
flux. How we are
flux. How we are
controlling by
controlling by
voltage across
voltage
the
across the
armature,
armature,
applied
applied
voltage, and
voltage, and
depending upon the
depending upon the
various
various
methods of
methods
speed
of speed
control.
control.
And we have
And we
discussed
have
about
discussed
the
about the
those
those
methods in the
methods in
last
the last
session. How we
session.
are
How we are
controlling by
controlling
using
by
the
using the
potential
potential
divider
divider
control and
control
applied
and applied
voltage
voltage
control.
control.
I think we
I
have
think we have
discussed the
discussed
speed
the
control
speed
of DC
control of
series
DC
motor
series motor
using
using
field
field
divider
divider
method and
method
also
and also
armature
armature
divider
divider
method.
method.
Uh,
Uh,
and we
and
have
we
discussed
have
about the
discussed about the
tapered field
tapered field
winding, which I
winding,
have
which I
said
have
like a,
said like a,
regulator of a
regulator of a
fan,
fan,
so that you can
so that
control
you can
the
control the
field winding
field
by
winding
using
by
it as
using
a
it as a
regulator
regulator
for the
for
input
the
of
input of
armature
armature
winding. So
winding.
you can
So you
control
can
by
control by
using the
using the
taper field
taper field
winding.
winding.
And we
And
have
we
discussed
have
about the
discussed about the
serious
serious
parallel
parallel
connections
connections
of
of
field.
field.
In this
In
method,
this
the
method,
field
the
coil
field
is
coil
divided
is
into
divided into
various
various
parts.
parts.
That means
That
these
means these
parts
parts
can
can
be
be
that
that
can be
can be
connected in
connected in
series or
series or
parallel as
parallel
per the
as per the
requirement.
requirement.
Uh,
Uh,
that's have
that
shown in
have
the
shown
figure.
in the
I
figure.
think you
I
are
think you are
familiar with the
familiar with the
series and
series
parallel
and parallel
connections. You
connections.
can
You
see in
can
the left
see
hand
the
side
left hand
there is
side
a
there is a
series
series
connections,
connections which
which
are
is
the
for
input
an
for an
armature
armature
winding of a
winding of a
motor,
motor,
and at right
and
hand
at
side you
right
can
hand side you
see
can
the
see the
parallel
parallel
connection,
connection,
which is the
which is the
input for the
input for the
armature
armature
winding of the
winding of the
motor.
motor.
Next, we will see
Next, we
what
will
is
see
the
what is the
rheostatic
rheostatic
control.
control.
In
In
previous
previous
control,
control, you have
familiar with the
familiar with the
rheostatic control,
rheostatic
which will
control,
be
which will be
connected with
connected
the
with the
field
field
winding.
winding.
If
If
you
you want
control
to
the
control the
flux,
flux,
the
the
rheostat will be
rheostat will be
connected with the
connected with
field
the field
winding.
winding.
If you want
If
to
you want
control
to
the
control the
armature, so the
armature, so the
rheostat will be
rheostat will
connected
be
with the
connected with the
armature winding.
armature winding.
So
So
depends
depends
upon the
upon the
variable
variable
resistance
resistance that
that
is
is
known as
known as rheostat
rheostat
is
is
inserted in the
inserted in a
series with the
series with the
motor. That
motor.
means
That
it may
means
be
it may be
connected with the
connected with the
armature winding, or
armature
it may
winding,
be
or it may
connected
be
with the
connected to the
series with the
series
motor.
winding.
It may
Whatever it
if it
may,
is
if it
connected
is
with the
connected with the
motor,
motor,
the
the
voltage drop
voltage drop
across this
across this
resistance, that is
resistance,
the
that is the
IA or
IA
X,
or
that
X,
is
that is
the voltage
the
drop
voltage drop
across the
across the
RX, that is
RX,
you
that
will
is
say it
you will
as
say it as
IA and the
IA and
resistance
the
value
resistance
of the
value of the
RX.
RX.
So occurs
So
this
occurs
reduce
this
the
reduce the
voltage
voltage
across the
across the
armature. So you
armature.
can
So you
see
can
in the
see in the
diagram
diagram
at the right
at
hand
the right
side
hand
there is
side
the
that is the
graph in
graph
between
in
the
between
speed
the
and the
speed and
current.
the current,
That is
that is
with the
with the
RX to,
RX to,
if it is
if
with
it
the
is
RX,
with
the
RX,
speed
the
will be
speed will be
higher for the
higher for
reduced
the reduced
current. But
current.
if it
But
is
if it is
without
without
RX,
RX,
the current
the
will be
current will be
increased and the
increased
speed
and the
will
speed will
also
also
be
will be
increased in
increased
the
in the
rheostatic
rheostatic
control method.
control method.
What is the
What is the
applied
applied
voltage
voltage
control
control
method? Here
method?
you can
Here you
see
can see
at the right
at the
hand
right
side
hand
there is a
side there is a
motor, and the
motor,
left
and the
hand
left
side there
hand
is a
side there is a
generator
generator which is
coupled with the
coupled with the
permanent
permanent
magnet.
magnet.
PM is the
PM is the
permanent
permanent
magnet
magnet
which is
which
coupled
is
with the
coupled with the
permanent
permanent
magnet,
magnet,
and there is
and there
a
is a
generator
generator
field.
field.
So
So
the
the
generator field
generator
is being
field is been
controlled by
controlled by
using the
using the
rheostat control,
rheostat
that is
control, that is
RX. So
RX.
the
So
speed
the
of the
speed of the
generator is
generator is
controlled.
controlled.
So
So
depends upon
depends
the
upon the
speed,
speed,
we will have
we
the
will have the
variable
variable
voltage.
voltage.
If you are
If you are
varying the
varying the
speed of the
speed of the
generator, the
generator, the
voltage will be
voltage will be
varied. If
varied.
you are
If you are
reducing the
reducing
flux
the
of
flux
the
of the
if you are
if you are
reducing the speed
reducing
of
the
the
speed of the
generator,
generator,
voltage will be
voltage will be
decreased.
decreased.
If you are
If you are
increase the
increasing the
voltage,
voltage
speed of the
speed of the
generator,
generator,
voltage will be
voltage will be
increased.
increased.
So
So
it
it
depends upon
depends
the
upon the
generator
generator
field. You will
field. You
have the
will have the
variable
variable
voltage to this
voltage to
motor.
this motor.
So the
So the
voltage
voltage
obtained from the
obtained from the
generator is
generator is
controlled by a
controlled by a
field
field
diverter
diverter
resistance
resistance
connected
connected
across the
across
field
the field
winding
winding
of the
of the
generator.
generator.
So
So
in the
in
next
the
you
next
can
you
see
can see
that is a
that is a
broad
broad
Leonard system
Leonard
of a
system of
speed
a
control.
speed control.
Moreover, this
Moreover,
system
this
has
system
been
has been
utilized in the
utilized
lift.
in the lift.
Nowadays,
Nowadays, we are
utilizing
utilizing
the
this
system in the
system in
lift.
the lift.
That means
That means
there are
there
two
are two
motors, that
motors,
is
that is
M1 and
M1 M1 and M2,
which
which
is
is,
has
which
been
has been
coupled with
coupled
the
with the
generator. We are
generator. We are
assuming
assuming
in
in
between
between
G
G
is a
is a
generator.
generator.
So
So
it is
it is
coupled with
coupled with
the
the
generator. That
generator.
is
That
the
is the
each
each
motor will
motor
be
will be
coupled with
coupled with the
the generator.
generator.
So
So if
if
it is
it
the
is the
Ward
Ward
Leonard
Eigner
Eigner
method,
method,
it is
it
a
is a
free wheel
free
is
wheel
used
is
in
used in
addition to
addition to
motor
motor
generator
generator
sets.
sets.
Means if
That is,
one
if
motor
one
is
motor is
acting as a
acting as a
forward bias
forward
and
bias
another
and
motor
another
will be
motor will
acting
be
as a
acting as a
reverse bias.
reverse
So
bias. So
this method
this
is
method is
commonly
commonly used
employed
employ
for
for
elevator, hose,
elevator,
and
hose,
main
and
drive
main
in
drive
steel
in steel
mills.
mills.
What are the
What are the
advantages and
advantages and
disadvantages? For
disadvantages?
smooth
For
variation
smooth
of
variation
speed,
of speed,
override wide
override
range,
wide range,
rapid
Rapid and instant speed reverse speed control above and below rated is possible. Good speed regulations, efficiency is low, initial cost of setup is very high. So these are the advantages and disadvantages of Ward Leonard method. And what are the conclusions? That means the factors affecting the speed control of DC machines, different methods. That means that is different methods of advantages and disadvantages is explained in detail with the suitable diagrams. Wall Leonard system of speed control is always discussed because the main theme of the speed control is Ward Leonard system. It is the very important system which you have to be very much familiar. These are the reference book which I have been discussed. That is Principle of Electrical Machines and Power Electronics from John Wiley, and the Electrical Machines of PHI Learning, that is PVT Limited, the New Delhi, and the BS Bindra, that is Electrical Machinery, Pana Publishers, and Sharma and K Path Electrical Machines, NCatch Learning Private Limited, and E. Bakshi and M. Bakshi are Electrical Machines. One technical publication. Those are the reference book I have taken for the speed control methods. Let me have the next session, that is the speed control of three-phase induction motors. That is from the electrical machines and drives, which has been the part of the syllabus of mechatronics engineering. That is which you can see in this slide. So, what is the agenda? If it is the speed control of three-phase induction motor, that is the agenda are the introductions. What are the requirement of speed control, and what are the types of methods to control the speed of induction motors, advantages and disadvantages, industrial applications of AC types. So, those are the agenda which we are going to discuss about the speed control of three-phase induction motors. So, if it is an introduction, if it is a three-phase induction motor, is basically a constant speed motor. So, if it is a whatever a induction motor, moreover, we are utilizing the induction motor at a constant speed. It is widely used in industry due to low cost and rugged constructions. Then a speed control of induction motor is done at the cost of decrease in efficiency and low electrical power factor. So those are the main theme of the induction motors. So for those applications oriented and advantages, we are replacing the induction motor at different applications. This you can see one of the shot which I have taken from the online platform, that is the induction motor driving sealed air fan for supercritical boilers at Dani TPP in Gujarat. So it is a supercritical boilers which we are mostly replaced at the thermal power plant. So where we are replacing the three-phase induction motor for driving a seal air for supercritical boilers. So what are the requirement of speed control? Speed control means change the drive speed as derived by the process to maintain different process parameters at different loads. Energy saving. Speed control is a different concept from speed regulation, where there is natural change in speed due change in load on the shaft. And the speed control is either done manually by the operator or by means of some automatic control device. Low speed starting requirement. Those are the requirement of speed control if you want to control the speed of an three-phase induction motors. What are the methods? How we are controlling the three-phase induction motors or induction motors? There are different methods that we will discuss. That are the stator control, stator voltage control, stator frequency control, stator current control, and V by F control. That is voltage by frequency control method, and static rotor resistance control. So those are the methods to control the speed of the induction motors. Depends upon the application where we are utilizing the speed of the induction motor. So the stator voltage control, that is the synchronous speed, NS, that is the 120 frequency by P. If it is a slip, that is we can say it as the NS, that is speed ns minus n divided by ns. If you want to calculate the torque, you can go for T is equal to 3 by 2 pi ns into e square 2 or 2 by r2 square into x2 square, where e is the rotor in EMF and ns is the synchronous speed which already mentioned in the first formula itself, and r2 is the rotor resistance and x2 is the rotor inductive reactance. Those are the formulas which we will be discussing while solving the problems. So, if it is the rotor resistance, R2 is constant and if slip is small, then Sx2 is so small that it can be neglected. Therefore, T is directly proportional to S E2 square, where E2 is rotor induced EMF and E2 is directly proportional to the voltage. And hence torque, that is T is directly proportional to E square. Thus, if supplied voltage is decreased, torque decreases and hence the speed decreases. This method is the easiest and cheapest, still rarely used because a large change in supply voltage is required for relatively small change in speed. That means if there is a large change in supply voltage will result in large change in flux density, hence disturbing the magnetic condition of the motor. So this is the graphs depends upon the large changes in the flux. There will be a large changes in the motor. So there, if there is a large changes in the motor, there will be large changes in the torque. What is the frequency control method? That is the synchronous speed of the induction motor ns equal to 120 f by p, where f is the frequency of supply and p we can say it as a number of stator poles. Thus the synchronous speed changes with the change in supply frequency and thus running speed also changes. This method is not widely used. This method is used where only the induction motor is supplied by a generator so that frequency can be easily changed by changing the speed of prime mover. So by changing the frequency, we can control the speed up above and below the rated speed. It offers high range of speed control. That is, we can draw the graph in between stator frequency and the torque. You will have the maximum speed, that is MD, and you will have the ratio speed which have been split into five different types of graphs. So what is the stator control method? That is TM, that is VR equal to 3 XM ISDC and by omega synchronous square. So if you want to calculate the starting torque of induction motor, IM is the short form of induction motor and T is the torque is proportional to the square of stator current and it is independent. It is independent of supply frequency. It is independent of rotor resistance. So
Next video. Thank you.